to say, okay, I want to get a copy of all SMS from this number. And basically, that's all done either through the web or through simple, like responder, voice responder. So, very interestingly, as companies that do LIG are mostly Israeli companies. And very interestingly also, the telco operator don't get access to the LIG. They just have to, they know that the government told them, you are going to pay for this equipment, and a bunch of Israeli guys are going to show up and install some system right in the middle of your backbone, what we call the core network. And you don't have to worry about this, these are professional. And then they're deploying a system on which the telco doesn't have even access to. So it's very good for the telco because they say, oh, in case of liability, in case of someone tapping on the prime minister or else, that's not my responsibility because I don't have access. So they don't care if it's a huge hole into the network because it's not their liability. End of the story. Well, we'll see maybe that it created a lot of problems in the future, and well, even in these slides. Now, current research started with mobile equipment, your equipment, the one you hold in your pockets. Research on the vulnerability. Colin Mulliner was presenting something about that, lots of research. What we have also is now the fact that we are getting our hands on BTS. So basically we are able to get to know better the radio protocol, and thanks to USRP, we are able to do some attacks like the one that Chris Paget and Carsten Knoll presented earlier, where there's definitive attack on crypto that can be carried on. Then we even commodify further the SS7 network by being able to replicate the BSC and BTS, and even further, actually OpenBSC even integrates a small HLR and VLR inside. Then we go into femtocell hacking, where femtocell is a 3G node, like a little access point, that will carry all the voice and signaling traffic to the network through IPsec tunnels, even bigger entry point. And then we have access to external APIs. Basically, it's web APIs. Last year, Tobias Engel, here present, basically showed us how to track mobile phones and how to get information such as which country and even which part of a city a mobile phone was remotely from anywhere in the world. Quite interesting. And, of course, basic fraud SMS injection. What I'm going to talk about is just scanning this. So we're going to see which kind of perspective we get on the whole core network. The problem when you're located here, basically on this side, is that even with the femtocell, it's just a reduced subset of the SS7 protocol that we are being able to connect and send messages with. The goal here is to do things which are much more impacting. Have you ever dreamed to make all the phone of one city ring all together once? We're really talking about this kind of stuff. So, okay, here comes TCP/IP from the 80s, but it's different. Let's say this is all ARP and low-level stuff. Basically, this is going to be phased out in the next releases by SIGTRAN. SIGTRAN is carrying all this stuff, which is above, by replacing this with IP. Great for us, we know this technology. Then SCCP is basic communication packet formatting. There's no sequence number. There's no complex tracking, identification, or whatever. If you want to start to have some kind of sequence that is completely predictable, you have to go as up as this. So that means that everything here, or even here, is actually without any kind of knowledge of sequence number. Or it's even worse than TCP in the 80s. Okay. What is important here, we are going really to focus on a few things because learning a set of protocols in, let's say, it remains now 40 minutes, is going to be a bit challenging. So we have mostly map, which is very interesting. When Tobias showed his API to, or the API of the company was using, it was basically injecting map message and waiting for response. This is everything that is relating to handover from handset, getting the country where you're roaming to, getting things which are quite unknown, like the fact that any roaming mobile gets assigned a local phone number. That's MSRN, mobile subscriber roaming number. So that means that each time you're getting to pay when you're receiving a call from one person in Germany to your French phone number, basically, you're being charged for something that could be completely avoided because you already have a phone number starting with +49. But nobody gives you this phone number. So the thing is, it's not filtered. And the telco have a lot of revenue leakage for this kind of stuff. And it's like blue box. Most of the time, they don't care because the fraud management system and fraud revenue assurance department just deal with massive fraud. Let's say some guys who bought a lot of SIM cards with like a full fare rate, and they insert that in SIM gateways, and then terminate traffic from the US in, let's say, Germany at the rate of customer full rate. So basically, it's the kind of fraud they are targeting is not the kind of fraud you get through hacking the network. Then we'll mostly talk also about SCCP. So SCCP is the easiest thing to spoof. Now, I'm going to be a bit sorry, but I'm going to have to speed up. I spent a lot of time here, and the next slides are going to be maybe a bit hardcore. If you have any question, ask me afterward. I'll be there for more time to party and to answer questions. Oh, it's the other way around. All right. Okay. Okay, so this looks like MSU. Message signaling unit are the basic block for protocol data on the SS7 network. Now, what is interesting is that we can start to see stuff we can scan. DPC is destination point code. Let's imagine an IP address is stored on 14-bit. That's the equivalent of IP address. It's called a signaling point code, and we can scan that. I'm going to try to always show the parallel between the SS7 attacks and the equivalent attacks in TCP/IP world. Then, of course, we want to do something related to injecting vulnerabilities, trying to get some content and to break some protocols. So here, basically, that's the first layer we're going to try to attack. Now, what we have to understand is that in TCP/IP, when you're sending a packet, you're sending from IP source, port source, to IP destination, port destination. That's the 4-to-play that you use all the time. With SS7, it's a bit different. When you send a message, you send it through an entry point. Let's say your physical connection to the STP, or let's say your connection to a SIGTRAN port, which I'll talk about later. And from there, the message is going to be forwarded to the destination, but maybe to more stuff. So little story. Once I was doing a pen test on some equipment and telco infrastructure, and as you all probably know, you do progress report. And so there's a progress report in the morning, and I tell my customer, oh yeah, so we did that and that and that test, and well, it failed, we didn't get any success, and basically he said, yeah, we couldn't manage to really get this stuff working. And it's like, well, wait a second, what exactly did you do? Oh, we tried to do this MML injection in some OMAP field, and blah, 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 blah. And like, oh, okay, interesting, because yesterday you crashed the legal interception gateway. So, so the most funny thing is that that meant that no cop could do SMS interception or phone listening, for phone eavesdropping for 1 day, and in the country for